Finally, we are here. Okay, so did I? No, here. Yes. So it looks like now is the week 45 already, yeah? Because we had the holiday and the week, so it has to be the week 45. But then we will still continue with this topic. Because maybe this topic won't take that long. We'll see. And then the final exam, no, midterm exam. Yeah, the final exam, that's also marked in the calendars. If somebody wants to do it, I have to put it into the only the examinarium because there's some kind of a project meeting on top of that time. So I can't be present. I can't do it basically, but it doesn't matter because with the midterm exams, you of course pass the course. But if somebody wants to do like a long exam of all the topics, then it can be done in the examinarium. Yes. So I will have to take this off. No, you don't have to do it if you did the midterm exams. But if for some reason, like, for example, your math skills were so good that you didn't go to the course at all and you just decided that you go to the final exam, that sort of makes sense. Just do it and that you get the credits. That's also one option. Yes. But I can't I can't do it this kind of like in the classroom final exam because there's something on top of it. Yes. So what else? Yes, but it's only so this I think this was the midterm exam too in the end of this month. And then the course is finished. Wow. That's how it's marked in the calendar. Okay. Then we are here. This topic. Oops. Yes. Still. And I promised that we could do some kind of mathematical proofing. But now I will get ready for this big thing. So you can still continue with the basic geometry exercises until then. The solutions are there as well. We were doing like one more on the last lesson because I was going through the exam, basically. So we will still try to do a couple of more of these. Maybe we did this one. Maybe we still didn't do this one. For example, you could continue now with this, and I just set the thing so that you don't basically you have a good use of your time being here. Okay, because this always might take a little while. I will see, for example, with how this program works. Sometimes it doesn't. It works, yes. Okay, so yeah, and then also this, you should prove the sign formula. Yes, maybe you already did it if you know how it's done. Then somebody of you maybe can tell how it's done. It's not that bad of a proof. Yeah. So if I do now this cosine formula for you, yes, this is what we agreed last time. I don't know if this is, and if you're not really interested, then you can also just calculate the exercise, yes? Because this is something like, I don't know, it might be interesting or it might not. Okay. Because I'm not going to ask you to do something like this in the exam, of course. At least mostly the Finnish students at least are only interested what's going to be in the exam. Is that a bad, what is it? How do you say, bad to say it like that? There's even some things wrong here. Yeah. Maybe this course, maybe the people here have been a bit different from the other students of other courses that I used to teach. Okay. So cosine formula, it says, and I always base everything on our lovely technical formulas. That has to be always correct. I'm not always correct, but this can't ever lie. Yeah. And there is this formula. I'll take it. Something like that, long thing. And then what it means here, for example, from this, so that here is one side, and then the other sides of this oblique triangle, which means that it doesn't have a right angle at all. Okay, so none of the angles is 90 degrees. So this side here is in power of 2 is these other sides in power of 2 are added, minus them multiplied by 2, and the cosine of this angle that's between them. Yes. And this is something that we've been now using in the our calculations. So then sometimes maybe you want to also know how these equations are formed. And of course, because you are all able now to study in English, even the Finns, you can see this kind of videos. There's so many, and for sure, many people do this a lot better than me. Yes. So if anything on these math courses you think that you should know better, or it wasn't being taught well here, you can find it anywhere. Okay, I'll do this anyway. This was the easiest way of doing it that I found, because I had to go through this myself as well, because it's not something that I commonly do on my classes. It's just, how would I say, waste of time, maybe. But maybe now it's not. Well, maybe that's, then you can decide if it was or if it wasn't. So I would make this like a coordinate system with the y and x axes, and then I mark here some points of an triangle like that, make a triangle. And make sure that this is not right triangle. Yes. There's no right angle. And then I mark the sides. A, B, C, they can be named whatever. And then I can mark the angles. And as you see also here, the angles can be marked either with the big letters in the tip. So here would be A would be against the B, B would be against B, C would be against C, and you can use either, or then with the Greek letters, alpha, beta, and gamma, and of course you can use any letters you want anyway. This is how it's commonly done. Okay. So now what I'm gonna try to show here, how I did it at home. I'm going to try to show you that actually in this picture, the A in power of 2 is C. No, let's do it in other order. It doesn't make any difference anyhow. B in power of 2 plus C in power of 2 minus 2BC cos alpha or A. I'll just maybe use the alpha. I'm more common in doing things like that. So how I would start this now is that I take some kind of like I mark here a distance on this x-axis, and I mark it with x. Yeah, this is some x distance here. And I do it so that I can draw here a right triangle, or even two of those. And then I start this, writing this proof. So from the Pythagoras, I'm trying to say it in the English pronunciation, I could see that this, I'm trying to get here now. So I start with the A in power of 2. That is this part. So I'm going to this triangle now. I have a right triangle here, and I know from the what Pythagoras has done sometime in the history that the y, I mark it with y now. Y in power of 2 plus this. So this would be y, this distance here. Y plus this c minus x in power of 2 is the A in power of 2. Yes? That makes sense? Yes. Now I try to get to the angles. So what I needed here was the this angle, yeah, because it seems to be there. And with the right triangle, I can of course like write this angle somehow. I have also here the right triangle, yeah. So this part x here, for example, can be expressed with that. And I know something here. If I start writing, for example, the sin A from the right triangle, I remember that it's this opposite. here, which would be the, check quickly. Yeah, which would be the y divided by the b. Yes. So then I could write again the y. What is the y? With the help of the sin of this angle and the b that is here in this triangle, yeah? So the y would be b times sin alpha. And then if I would write the cosine of this alpha angle, that would be the x divided by b, yeah, because it's the, so this was the opposite side, this y, and this x is the adjacent side, yes? So again, I could express this x with this angle and the b, yeah? X is b times cosine of the angle alpha. Oops, sorry, you can't see it. Let's put this somewhere else. Is this clear until now? Very clear, yes. Okay, so then I would start putting this, what I figured out into this, my Pythagorean theorem, yes? So my a in the power of 2 would be this b sin and this in the power of 2, yes? Then my c minus x, I'll write it here down so it fits. My c minus x would be c minus b cosine alpha, and this was also in the power of 2. Okay. And then I can start opening this expression. So that's what I need to do next. Basically, remove the brackets. And this is actually something now that we will do later on as well. For example, remove the brackets from this kind of an expression. For sure, most of you have done this sometime in school already, but we didn't go through it on this course. So if I remove the brackets from here, I would get b in the power of 2 and times the sin alpha, and this also in the power of 2. The way that these are marked is usually that the power of 2 is here for some reason. For sure, you've seen this kind of expression, maybe, or maybe you didn't. Okay, and then we have to remove the brackets from the other expression. Now I need my formula book. So I have here something minus something in the power of 2. And how this is done is something that we will go through very soon anyway. And I will write it, I will show it to you from here in the formula book. So this is already in the page 8. Here, this and this. And why? Because you can just go through it yourself, just multiply to a minus b times a minus b, and you get into this kind of an expression. But this is just a shortcut that's shown here in the formula book. Yes? Who has seen this before? Maybe most of you have seen this before. Yes. Okay. So I write it somewhere here that I took something from the technical formulas, page 8. And I just used it. So I know that a minus b in the power of 2 is a in the power of 2 minus 2ab plus b in the power of 2. So now I will have to do this to this. And you can think it through yourself also. So I put here the plus. I will put it on this line so that it fits again. So it's the first here in the power of 2, which would be c. c in the power of 2. And then it would be minus, then there would be 2. Then there would be the first term, which is the c. The second term, which would be b cos alpha. And then there would be plus this whole thing again in the power of 2. B cos alpha in the power of 2. Are you still following? Does this look reasonable to you? And if not, well, doesn't matter. I don't know. Okay, so now we would need to simplify this, basically. Now we are already close. Even if it doesn't look like it to this expression where we want it to go, we just have to simplify that formula. So this is where we were aiming to. We're almost there. Let's do it. So a in the power of 2 is, I will still let this to be look like this. In then there was the plus c in the power of 2. Then there were minus 2cb. Well, I put it that way. Let's put bc. It looks more like that one there. bc cos alpha. And then I remove the brackets here. There would still be plus b in the power of 2 cos alpha in the power of 2. What's the problem now here? Why isn't it still like this? Why doesn't it look like? Why isn't it this? There, for sure, there's at least this thing that we have to get rid of. Do you know how to get rid of that? Yes, exactly. So some of you for sure already knew how this was done. So let's organize these things a bit. I have here a b is multiplying both sin in the power of 2 and also cos in the power of 2. This is here and this is here. So I can take a common multiplier. I do that, for example, first because it was there. There is the sin in the power of 2 plus cos in the power of 2. Then I have still the plus c in the power of 2 and minus 2bc cos. Yes, we are almost there. So now look, there's the C, then there's this, and now this is the problem here. But some of you already know what it means. If there's a sin in the power of 2 plus cos in the power of 2. Who knows? Is it only you? What is it? Yes. This. We are there actually. We did it. This is 1. Huh? Why? This is 1. So if when you do it like that, just get rid of it. This looks quite simple, yeah. And now we are just there. Okay. Who knows why this is 1? Do you want to know why it's 1? Okay. Still quickly that thing. That's a matter of the engineering mathematics too. Aha. So yes, well we managed, and that could be all here, and we got a result. Who could follow this until here, and now this is a bit unclear? Most of you, yeah? Okay. So we have this kind of a thing called unit circle. Who has ever met this guy? Nobody wants to meet him. The students, when I taught this whatever course, they said that don't ever go to the unit circle. And we didn't then. We just did things different way. So the unit circle, what it would mean, now this is going to be very small. Let's take 1 unit here. So this is obviously 1. It's like one step to every side, and that could be a circle then. Yes. That's it. Okay. Then if we take here, and let's say that the radius here is always 1. Yes. Whenever I go round this circle, there is the radius is 1. So I can draw here an angle. Let this angle be, for example, alpha again. Now this is like really, sorry, this is really small. I could draw this a bit bigger as well. Well, okay. Then if I start writing again these things, I start figuring out through the right triangle sin of the alpha. For example, that would be the opposite, yeah, the opposite here. And let's mark it with y, like we did. It's the y-axis, basically. Here is y, and here is x always. Y divided by the hypotenuse, yes? The hypotenuse here, this, is always 1, because it's the radius, yes? Which means that y is sin alpha. Okay. If I start writing again the cosine of this, it's the x here, yes? The adjacent side. I can mark it with x. Divided by the hypotenuse, but that's always 1. This is how beautiful this unit circle is. Yeah, very handy. Unit circle is the best. So this is cosine alpha. And then I know also here, this triangle, if I start calculating the hypotenuse here. So if I go take my dear Pythagoras, into action again, I know that this hypotenuse here, which was 1, yes, in the power of 2, is my y in the power of 2, or plus my x in the power of 2, or my x in the power of 2 plus my y in the power of 2, yes. So that would be sin alpha in the power of 2, and here I marked it like this, yes, plus cos alpha in the power of 2. This is where it comes from, my dear unit circle. Who likes unit circle now? We will be using this after Christmas, not immediate. But it's very simple, actually. It's just something that's maybe is expressed in a difficult way. But if you didn't like unit circle yet, for sure you can find many pro videos in the YouTube, for example, where you can get familiar with it also. Okay, so do you believe now that this did it go? Is this correct now? Yes? No? Yes. Maybe. Now do the proof of the other formula, the sine formula, the way that you want to, or you find from somewhere. You don't have to figure it out yourself. You can just Google it, watch the video, or ask the ChatGPT or whatever, as long as you realize what happened there. And then one of you could come here and show it to us all, yes? And explain it. And maybe even if you already know, that's also possible. Who wants to already come here and show the proof if you already did it? Okay, let's give it a little bit of time. And if you're already done then you can continue with the basic geometry exercises as well. Yes. And this is still, we can use this lesson for that. Oh, okay. And then we can go to the next topic. Mm. Hello, sorry about that. I had to. That happens. Okay. So has somebody now been preparing the proof? Yes. Okay, cool. So would you come here and show it? That would be so nice. Thanks a lot. Could you
I don't know.
explain it? Yes?
So there's sine formula, and I just like compare it to the right triangle formula.
Yes. Wow. Okay.
So I'll get that from so 90 is 1, and it's same as in the right triangle form.
Mhm. Yeah, so if you get it from the right triangle.
Yeah.
Mm-hmm. But if it's not a right triangle. Okay. And anybody else? Do you have also? Yes. Okay. Can you show it and explain? Yes. Thanks a lot.
So it's like this. I took this and I got y value from this triangle and this triangle.
Yes.
So it's like here sine A equal y over b. So it's y equal b sine A. So it's my first formula. From the second triangle, I got sine b, which is y over a. So y equals sine a sine b. So the way this is equal to this.
Mhm.
So b sine a equal a
Yes,
sine b.
Yes,
So
yes.
it's like this.
Yes. So this is a bit similar as the proof for the cosine formula. Yes.
Yeah.
Did you figure this out yourself?
Yeah.
Oh, yes. So then this looks quite clear, yeah. Who thinks this is clear? Did you do it the same way? Do you have some other kind of proof? Does somebody else still want to show? Yes.
Shall I take one?
Would you like to go through this more clearly, more slowly or something? Or ask about it? I had a bit different kind of as well, but I'm not gonna like this is I think this is really nice. Yeah? Uh who understands this? Hmm? Okay, should I still do this once more, or do you want to do something different? Do you want to look it from there, or would you like me to still sort of do it like slowly, like I tend to do things? Okay. Who thinks I should still go through this to you? Is it clear? It's clear. Okay. Okay, maybe I have to take a picture of it so that I don't forget. Who was able to do this proof by themselves? By some means. This can be, for sure, it can be done many ways. Do you like this kind of maths? Or is it like nice or okay? Yeah, there's this, so this is part, this is this. Okay, thank you. Okay, and thank you as well when you showed your thank you as well. Maybe it maybe demands a little bit of courage to show your own thinking. Yes. It doesn't always have to be correct because it's just then you figure out like maybe it also takes courage to show what you have been thinking. Should we still go through one of these? What did we go through last time? Calculate the line X. There's many ways of doing, for example, this exercise. Who has calculated the exercise 7? But we still have time to go through that. The easiest way to do this was to actually draw it to the triangle here. That was, now I remember actually this. So if you see something like this, but for sure there's many ways. Many ways. Here, maybe it was shown that it was drawn into a triangle. That's my equipment. Yes. Well, maybe it can be seen from here. Don't restart. Mhm. If I take it a bit bigger. So you have something like this, because then we will do a lot of geometry after Christmas. If you see it from here and then you start drawing some lines, and for sure you can calculate this many ways, but you can also expand it to the right angle triangle from which you already know some features. If you, for example, know that here is the angle 45, here is an angle 90, it means that if you expand it to the triangle, you have to have the angle 45 here as well, yes? So this was, then it's sort of easy to solve anything from there. This was what was done here in this. So I would have known that the angle 45 is also here. And then I can start when I know some lengths of some things, I can start solving it. Yeah, I, for example, know some, so this is some dependencies of an triangle. If I have here 45 angles and here 90, for example, these sides here have to be equal, even if they wouldn't look like it. In this picture that I have drawn here. Who has done these exercises already? Were they who these little exams, little quizzes? They were pretty simple, yeah? Simple. Should we be now just happy with the this geometry and then go to the next topic? And maybe then we continue this topic after Christmas. Yes. So the next topic of this week will be this quadratic equation and function, radical function. And this is for sure something that most of you maybe have already done before. Somebody here won.